Alright, in the last video, we graphed tangent of x. And we did that by plotting points, and we realized that the shortcut way to do it, to find the key points that you need and to graph this, you are to start with the center point, move over the period, which for tangent is pi over b instead of 2 pi over b. Okay, and once you have the second point drawn, there's a vertical asymptote that happens in the middle of that. And then whatever this distance is here is the same as going back that way. And then we know that there are these halfway points, or quarter way points, quarter of the period, and they go up and down to 1 for regular tangent. And then you can draw one period. If you wanted to draw more periods, you could, because it is a periodic function that repeats over and over again. So it would look like that. So again, just real quick, the way you draw this is start with the center point, move over the period, halfway in the middle is your asymptote, go back and get the other asymptote, quarter of each way, and then draw your two other points. And that is how you draw a tangent. So for today's video, we are going to graph cotangent. And we could go about this by plotting a bunch of points and plugging in angles into cotangent to figure out what the output is going to be, remembering what we have on our note cards, remembering that cotangent is cosine of x over sine of x. But I'm just going to go through the graphing a little bit more quickly because it's very similar to what tangent is. But what you should notice here is because sine is on the bottom, it's going to be 0 on the bottom at different angles than tangent was. So let's think about that. Sine is the y coordinate. So as you're looking at the graph, as you're looking at the unit circle actually, when is the y coordinate going to be 0? Well, that's going to happen at angle 0 and at angle pi. So cotangent of 0 is undefined, and cotangent of pi is undefined. And the undefined points are what determine where the asymptotes are. So when we go to draw cotangent, instead of starting at a center point, starts on an asymptote. And then we move over the period. The period for cotangent is the same as tangent, it's pi over b. So we move over the period and put another asymptote. That's going to be where cotangent of pi would be. So you can see that that's the distance of pi, the period. And then halfway in the middle of that, which would be pi over 2, that's going to be equal to 0, because cosine of pi over 2 is 0. That'd be this angle up there, if you're trying to put it all together. And then we have these quarter way points, which are going to be similar to these quarter way points. The difference here is that for cotangent, the first one goes up and this one goes down. And it looks like that. Okay, so this point here, which is pi over 4, is positive 1. This is negative 1. So that's how we get those quarter way points. And then if we wanted to, we could continue this on. It would look like that, or we could go backwards. It would look like that. So if we wanted to do, let's do another example. Or should we write out steps? Let's write out steps. So the first thing you want to do, cotangent starts on an asymptote. So you want to start it asymptote. And then you're going to move over the period. And draw another asymptote. halfway in the middle, it's a center point, and the quarter waypoints go up one, down one, and it starts going, goes in the negative direction, it decreases, as long as A is positive. Okay, so that is how you go about graphing cotangent. So let's do an example where there are numbers involved. Let's do, 3/2 cotangent of, we'll say 2x over 3. I don't know what that's going to do. That might be ugly. Minus, we'll do plus pi over 3. And then we'll go plus 1. Okay, so the A value is 3/2, so we're going to have a vertical stretch of 3/2. Again, we don't say that it is a amplitude, because amplitude is a word that is involved with sine, like with waves. So this isn't a wave. The midline, we also don't call it the midline. We would say it's a vertical shift of up 1. So we don't say midline, we say it's just been shifted up 1. And then we need to find the period, which is going to be pi over 2/3, which will simplify to 3 pi over 2. That doesn't seem too bad. Guess we'll find out. And the phase shift is not a phase shift for these, because there's no phases. The horizontal shift is going to be left, and it's going to be pi over 3 over 2 over 3, which is pi over 2. Okay, so let's see if we can put all that information into a graph. Okay, so the first thing we want to do is we want to move left pi over 2, which is going to be here, and we're going to put an asymptote, because you start on an asymptote. And then you're going to move over the period, which is 3 pi over 2, so that's 1.5 pi. Here's a half pi, here's 1 pi, and then you put your second asymptote. And then we have to go in the middle of that. To find the middle, I'm just going to count how many of these blocks there are. 1, 2, 3, 9, so I got to go 4.5. 4.5, and I'm going to put, I'm not going to put it there though. I'll go to a different color since I screwed that up, because I have to shift that up 1. So there's shifted up 1. And then I have to find the middle here, which is going to be right around there. And the middle here is right around there. And because there's a vertical stretch of 3/2, and we know that it goes like this because it's positive, I got to go up 3/2, which is going to be right around there. Down 3/2, which is going to be right around there. And then I can draw my curve, which looks very straight going through here, but it does curve. And that is how you draw a cotangent graph. One other quick thing to notice about these trig functions. So let's just say that we have tangent of x, which we know starts at a center point. Move over the period. It's going to be here. Halfway is going to be an asymptote. Then down to the quarter waypoints. We draw that. Let's draw cotangent in blue. So we know it starts at an asymptote. Move over the period. Halfway in the middle. That point. Goes like this. And just for fun, let's throw on here sine of x, which sine of x starts at the origin, move over the period, halfway in the middle, up to the maximum, down to the minimum. That should be pretty commonplace in your minds now. So there's sine, and I didn't have a fourth color. What would show up here? Pressure. Let's do this orange color. for cosine, which starts at its maximum, moves over the period, halfway in the middle is at its minimum, then these points here and here, and it goes like this. And this looks like a jumbled mess, but there's something I want to show you guys. So if you look in this region from here to here, this is from 0 to pi over 2. That corresponds to, in the unit circle, these angles, the first quadrant. And you can see that for these four functions in the first quadrant, all of the graphs are positive. They're all above the x-axis, right? Tangent is the purplish color, cotangent's the blue, there's cosine and sine. Everything's up there. It's all positive because in the first quadrant, they're all positive. Now if we move to, I'm going to quickly run out of colors here. The second quadrant, that is this region right here. And in this region, you know that sine is positive, and you can see the green is positive, while cosine and cotangent, and I didn't continue tangent here, but if I drew another period of tangent, it would look like this. So that might be useful to do, and I don't need to draw cotangent. All right, so in this region, sine is positive, cosine, tangent, and cotangent and tangent are all negative. And then if I go into the third quadrant, which is here and here, you can see that sine and cosine are negative, but tangent is positive. And if I had drawn cotangent, it would also be up there, but we don't need it. And then if I look in the fourth quadrant, which is here, you can see that cosine is now positive, sine is negative, and if I had drawn, I don't know which one of these is tangent. Is it this one? This one? Yeah. It would look like this. And so you can see that it would also be negative, right? Because it would be like that. So just showing you that the graphs are positive or negative in the quadrants as they should be. Just a little hint, though, for when you draw the, where's my cotangent graph, or tangent graph, you should know that between 0 and pi over 2, tangent is positive and cotangent is also positive. So that might help you keep track of where you're positive and where you're negative. I don't know. I think that's kind of neat that you can see that, so I thought I'd point it out. And that is all.